All right, in this video, we are going to look at complex numbers, which sounds difficult, but they are also called, you can also think of them as imaginary numbers. That's sometimes what they're called. Like I is an imaginary number. It's equal to the square root of -1. Now, why are we talking about imaginary numbers? Well, it turns out that they do exist, not like Santa Claus or something. They do exist, and they actually have real-world applications and meaning, like electrical engineering, physics, quantum physics, really high stuff that we will not get to talk about. In this video, I want to explain, where these, how we get these four. These are like the baseline that you really need. And then we're also going to use them to simplify powers of I. Now, they describe rotation and stuff like that. Now, this first one, this is a given. You have to have this one to have the rest of the pieces. This allows us to take the square root of negative numbers. So like if you were to try to take the square root of a negative in here, -9 say, you'll get non-real answer. But this allows us to give a definition to it. Now to figure out I squared, we're just going to do square root of -1, square root of -1, and they just say the radicals cancel. So when you multiply two square roots, the square roots just cancel, and you're left with -1. You're just left with whatever was underneath. All right, there's that one. And then I to the third, so this one's easy. This is equal to I to the second times I. Remember when you have, I to the first, I guess. When you have like bases, whenever the numbers here are the same, you can just add the exponents. And I to the second is equal to -1. So you really have -1 times I. And so this is equal to -I. And that's where that one comes from. And then for I to the fourth, this one's the one that's really handy, really important. I'm going to write I to the fourth as I squared times I squared. Well, I squared is equal to -1. So what we really have is -1 times -1. And that's where the 1 comes from. Okay? So write these down. These are going to be really helpful, especially whenever you're simplifying powers of I. All right, so they give us 55 i's. And what we're going to do is use the little exponent rule where we split them up. We're going to split them up in a fancy way. All right, you kind of have to be purposeful on the way that you do this. I'm going to split it up as I to the 52nd and I to the third. And you'll see why I did 52 here in a second. So the reason I did 52 is because 52 divides by 4 evenly. Now, what that means, the fact that it divides by 4 evenly, means that I can do this right here. I can think of it as I to the fourth to the 13th power. Because when you have a power to a power, you can just multiply those exponents, and that will end up giving you, well, I kind of attached it to the wrong line, didn't I? There we go. 4 times 13 gives us the 52. And when you have a power to a power, that's when you get to multiply those exponents. Now this I to the fourth, that right there, that's equal to 1. And so you get 1 to the 13th, which is equal to 1. All right, so I split it apart so that this number, the exponent here, divides by 4 evenly. And when it divides by 4 evenly, you can basically cancel it out because I to the fourth is equal to 1. And so what we're left with is I to the third, which is equal to -I. That's our answer there. I'm going to come back to this one. I to the 33rd. So I want to take off as many 4s as I can. Well, 4 goes into 32 evenly. So I get I to the 32nd times I. This one just cancels because you have so many I to the fourths. And you're left with square root of -1. Or you might just say the answer is I. Now this one, see this one, 76 actually divides evenly by 4. And so what you have is you have I to the fourth, I to the fourth, I to the fourth 19 times. So you really just wind up with a lot of ones. All right. So we want to find the closest multiple of 4 that comes before 118. All right, so 118 divided by 4 does not divide evenly. I know it's not an odd number, so let me try 116. There you go, 29. So it does divide evenly. So I'm going to rewrite this as I to the 116th power times I to the second. This one is just a bunch of ones. And I to the second, that's what that chart's for. I to the second is -1. And that'll do it.